Good morning, all. The next topic in transaction concept we'll see is multiple granularity locking. Here, multiple granularity locking is one of the concurrency control technique where locking is applied for based on the granularity. So, size of the data item allowed. So, what we'll see what is locking granularity. See, size of the data item allowed to lock, that is our locking granularity. So suppose based on the size of data item that is locked up, your data item size is very large, whole database it can be, or it can hold some it can hold only some tuples, that is tuples or attributes, or some records, or further whole database table only. So based on that size you are going to perform locking, that is called as locking granularity. So in turn there are two types of granularity, that is coarse granularity. In coarse granularity, what is happening? It refers to the large data item size. If you are going to lock on the entire database or entire relation, a relation is student is a relation, or faculty is a relation, or employee is a relation, on that relation you are going to perform locking, or whole database only. The relation will be like for employee relation or student relation. So whole table only you're going to lock, or whole database you're going to lock. So that is called as coarse granularity. Next we'll see what is fine granularity. Here it refers to the small data item sizes you're going to lock. Here you're going to lock like few tuples you're going to lock, or some attributes you're going to lock in one table. Only you're going to lock name and his roll number, or you're going to lock only his age. So this is called as fine granularity. Only few attributes, few tuples you're going to lock. Few tuples or few attributes you're going to lock is called as fine granularity. If whole relation or database you're going to lock, then it is called as coarse granularity. So multiple granularities protocol allow data item to be of various sizes and define a hierarchy of data granularities where the small granularities are nested within the larger one. See, in multiple granularities protocol, what is happening? Here the data items are distributed in various levels. It is like a hierarchy level. So small granularities means your tuples, your attributes all will be at the last level. So your tuples, all these will be at this level. Then these attributes will be further nested in, suppose name. If this is your first name, this is your middle name, and this is one more your last name, so this will be nested as one tuple. These are interns as one like one attribute. Then like this further these attributes will be in turn will be holding a relation. This relation further will be having a database. So this is a hierarchical concept or tree structure representation given to the multiple granularities. So as different transactions have different requests and require different levels of log granularity on the basis of the operations being performed. See, in this here there is figure, there is a tree here. So at different levels, see this is your database, this is your database, and these are F1, F2, F3 are nothing but your, see this is a multiple granularity tree where R1 these bottoms are your records, R11 these are your tuples or attributes, you can tell, R11, R12, R21. so further this is nothing but your fine granularity that we are going to apply on the attributes F1, F2, F3. These are the files, these are your files, these are your records, this is your database. So at these different levels different types of locking can be applied. At the record levels, a fine granularity will be applied, at this level, files level and database level, a coarse granularity will be applied. So this is your multiple granularity tree. So at different levels, different types of locks will be applied based on what type of operations you're going to do, at like which particular place you're going to perform operation, there the lock will be applied. So we'll see with an example. If a transaction wants to modify a particular tuple will be at the leaf levels, then only the tuple need to be logged. See, at this records will be having a tuples. So here R11, R22. So at this place, if you want to perform modifications like read, write or execute, then here you are going to apply lock. So what type of lock you will be applying? Here we will be applying a fine granularity lock, which is applied on the tuples or attributes. So if a transaction wants to modify or delete a multiple tuple, then it requires an entire relation to be logged. If more than one records it want to update, suppose I want to perform modifications on R11, suppose I want to perform modifications on R21, R22 and R33, then I should apply lock on F2. So that lock is nothing but my coarse granularity lock. At this level, if I apply lock, then all these 3 records will get logged. So based on the level, based on the updation operation that you're going to perform, based on that you're going to perform locking. If I want to perform modification only on the records, then I'll go for the fine granularity. If I want to perform modifications on set of records, then I'll go for the locking, that is coarse granularity locking, that will be done at the higher level. So for this reason, it provides, for this different types of modification, it provides a range of locking granularities. That's why it is called as multiple granularity locking. The hierarchy of the data items of various stages can be represented in the form of tree, as we have seen, because it is at the various different stages and all are having in turn the information, then it is called as hierarchy representation of this record. See, in tree, small data items are nested within the large data items, as we have already seen. R11, R12, this information will be nested in F1. R21, R22, R23 will be nested in F2. Further, F1, F2, F3 will be nested in database. So this is the hierarchy level of database representation. So we'll see the operation that we can perform. Suppose when a transaction perform locks, here we already have seen there are 2 types of lock. One is shared lock and another one is exclusive lock. One is shared lock and another one is exclusive lock. So if I'm applying shared lock, if I'm applying shared lock at this particular level F1. So if F1 is applied shared lock, that is read, it can only perform reading in shared lock. Then R11 and R12 also I can apply shared lock. Then R11 and TI is a transaction that is going to apply a, one second. See, when a transaction locks a node in the tree, then it implicitly locks all the nodes descendant in the same mode. That is, if shade lock is applied for F1, then R11 and R12 also shade lock will be applied. If I'm going to apply explicit lock, that is for writing purpose, read and write, then R11 and R12 also will be applicable for exclusive lock. If whole database only I'm applying shade lock, then all the places I can open for reading purpose. If exclusive lock is applied on the database, then all these hierarchy level files I can open for exclusive mode. That is these are the transaction locks. See, if in other case, what happens if TI is applying F1 with exclusive lock? If TI is applying exclusive lock here at this place, if it is applying exclusive lock at F1, then the below request R11 and R12 is requesting for shared lock. As we have seen our compatibility matrix table, here what is happening in shade and X, X and S. See, if shade and shade we can have, it can perform sharing, but rest all places no, it can't perform. Only shade and shade, that is for reading and reading, you can open with other transactions. If one transaction is performing reading, then other n number of transaction can also open the same instruction for reading. But whereas in exclusive, if one is performing exclusive, then none can open for any other operation. This compatibility matrix we have already seen. So the same concept will be applying here. If any one level is applying exclusive, then the below levels no one can open it for shade purpose, that is for reading purpose. If at this place if I am applying exclusive lock, then the below I can't open for exclusive or for shade also, so it will reject. To check whether it is to see, suppose at this level I'm asking requesting for the S lock. At R11 level I'm requesting for the S lock, then it will start checking from the root level. It will check at the this root level, that is the database level. Then it will come for the F1 here, as it is already applying exclusive lock. Then it will further it can't execute, it has to wait for the instruction to finish. Then after finishing only, then this shade can be given to the R11. Till that time it has to wait for the F1 to finish its execution. So this is all about how locks have been granted at the different levels of the multiple granularity tree. Thank you.